Okay, so for this problem, they give us this graph here, and they tell us that f is continuous and has 3 line segments and a semicircle, and g is the function given by the integral from 1 to x of f of t. So first we're supposed to find g of 2 and g of negative 2. So for g of 2, we're plugging in 2 for our x, so we'll be integrating from 1 to 2 f of t dt, which is the graph that we have right here. So we are looking from 1 to 2, we're looking at the area underneath the curve there. So from 1 to 2, that's the triangle, 1/2 times, you have a base of 1 and a height of 1. So that, actually, no, we do not have a height of 1. We have a height of 1/2 because right here, this is a 1, so this would only be 1/2 right here. So 1/2 times 1/2 is going to give us 1/4. This is below the x-axis, so that's going to be a negative 1/4 there. So g of 2 equals negative 1/4. And then we're going to do the same thing, but with g of negative 2. So we are integrating from 1 to negative 2 of f of t dt. And here we might want to think of this as negative integral from negative 2 to 1 of f of t dt. Because we're going backwards here, that area under the curve is going to be negative, or well, the opposite sign of. So from 1 back here to negative 2, we've got this semicircle and this tall skinny triangle. So we're going to have negative in the tall skinny triangle is 1/2 times the base, which is 1, times the height, which is 3. And we have our semicircle is underneath the x-axis here, so it's negative, so it's going to be 1/2 times pi times the radius squared, and the radius of that is 1, so pi times 1 squared. But now remember, it's the opposite of this, so we're going to have negative, and then we'll have 3/2 minus pi over 2, but you could leave it like this if you want, or you could distribute that negative, where you get negative 3 plus pi, and I'm just going to put this all over 2. So you can leave it like this, or you could even do this, pi minus 3 over 2. Any of those are accepted. Prime of negative 3 and g double prime of negative 3. Remember, this is g right here. So if we're taking the derivative, we're finding g prime of x, we're taking the derivative of the integral here, and derivatives and integrals undo each other, except for you got to plug this x right here in and multiply it by the derivative of x, but that's just going to give us f of x, and the derivative of x is 1, so you don't have to write anything. So you need to state this right here, g prime of x equals f of x. Then you can say g prime of negative 3, and that's just going to be f of negative 3. So right here on this graph, at negative 3, we have this point right here, which, well, actually I've drawn it a little backwards. It's right here in the middle of this line, so we know that's going to have a y-coordinate of 2 there. So g prime of negative 3 is 2. G double prime of x is equal to f prime of x, which is the slope of f. So g double prime of negative 3 is the slope of this graph at 3. And the slope of this graph here at 3 is 1. So you see we're going up 1 to the right 1. So g double prime of negative 3 equals 1. Okay? So we'll go on to the next part. For C, it says, find the x-coordinate of each point at which the graph of g has a horizontal tangent line. For each of these points, determine whether g has a relative minimum, relative maximum, or neither a minimum nor a maximum. So we know, we've already stated in the last part, we know that to tell where something is increasing, decreasing, maximums, minimums, we need to look at the derivative. So g prime of x is f of x, and we're looking for where that derivative equals 0. So this derivative right here that we have the graph of is going to equal 0 both at 1 and negative 1. Now here it says determine, first it says find the x coordinate of each point where the graph has a horizontal tangent. So we need to say the graph of g of x has horizontal tangents at x equals negative 1 and x equals positive 1 because g prime of x, which equals f of x, equals 0 at these points. So then we have to tell whether each one of those points, negative 1 and positive 1, are relative minimums, relative maximums, or neither at that point. And one of the main reasons that I chose this particular problem is because my solutions have a mistake in them. I looked at them, did not look at them closely enough. So at x equals negative 1, g of x has a relative maximum because f of x, well, let's call it g prime of x. I think f of x will be fine here since we've already stated that that's the same, because g prime of x switches from positive to negative. And at x equals 1, this is the part I had wrong on my answer key, g of x has neither a max nor min, and because g prime of x does not change sign. Okay, so that's the correct answer to part C for this problem. Make sure you justify your answers. You have to say because it doesn't change, the derivative does not change signs, or because it's from positive to negative there. Our last part is part D. From negative 4 to 3, we're supposed to find all values where g has a point of inflection. So we are looking at f, which is the derivative. If this derivative is increasing, that is going to tell us that the second derivative would be positive. And if this derivative is decreasing, that would tell us that the second derivative would be negative. So whenever we look at this, anywhere this graph switches from increasing to decreasing, you're going to have a point of inflection. So we do need to state here that g double, actually no, well, we've already stated that g prime of x equals f of x. So we're going to say that g of x has points of inflection at x equals -2. Also right here at x equals 0 and x equals 1 because g prime of x, and I just like to go ahead and put which equals f of x here so they're certain I know that's the case, switches from increasing to decreasing. Or vice versa. Make sure that you're talking about g prime of x here, not the second derivative, because g prime of x is the graph that you have. You can't really talk about that second derivative because you don't have the graph of the second derivative. If you want to say that this switches from increasing to decreasing, which makes the second derivative switch from positive to negative, you can do something like that, but this is sufficient here. Talking about that derivative switching from increasing to decreasing gives you points of inflection for